All right, let's have a look at grade staking here a little bit. So what I have here is a set of plans. On top, I've got a pipeline. It runs from station 0 plus 08 to station 2 plus 00. And as it does that, it rises in elevation. It starts with an eastern invert on this eastern side of the manhole at 221.04, and it goes up to 221.90. So what we would do is we would set a series of hubs. We pound them into the ground in this construction site, and we would put them along the course of the pipeline. We'd offset them a certain distance. The intent there is to get them out of the way of the construction. If we put the hubs right over the pipeline, they'd be dug up when they dug the trench for the pipe. So we're going to offset them, and you can see that offset there is 10 feet. Okay. We're also going to do a set of leveling calculations here, or leveling notes, where we're going to determine the elevation of the hubs. So that's done right here. And we're going to put all that together and do a little bit of arithmetic. And what we'll do will be to find the cuts and down from the hubs, right there, down to the pipeline, the invert elevation of the pipeline. So we're going to end up telling the contractor that they can go over 10 feet from our hubs, and then tell them how far down from the hub to go, and that's where they set their pipe. Now for starters, we use the plans, and we use the stations, which are kind of the distance down the line we're going, and then we use the elevations, which is how high the pipe is. So our first thing is to get the grade, which is just like slope in math. It's the change in elevation divided by the horizontal distance. So we're going to take our final elevation of 221.90, subtract off the original elevation of 221.04, and then divide that by the horizontal distance. Now what we're doing is we're running straight down a road here, so we can use our stations here to find the horizontal distance. We can subtract the stations, so take 200 minus 8 and we get 192. Take the difference in elevations and we get 0.86. Divide that out, we get 0.0045. We carry this out at least 4 places past the decimal. So that's the grade, or the slope of the line, as it runs up from station 0 plus 08 to station 2 plus 00. All right, the next thing we want to do is determine the elevation of the pipe at the different locations where we have the hubs. We've got the hubs at 0 plus 08 and 2 plus 00, and we've got those elevations. That's our starting and ending elevations. So what we need to do is to find the elevation of these other stations, 0 plus 50, 1 plus 00, and 1 plus 50. So that's what we need to do. So what we're going to do is use a relationship that's a lot like the mathematical equation y equals mx plus b. Okay, because we have the grade, which is like the slope in math, which is m. We can find the horizontal distance between our starting point and the point we want to find the elevation of, which would be like x. And then we have an original starting elevation, which is like b, which in math is the y-intercept, which for us is a starting elevation. So if we take the grade times the horizontal distance plus the starting elevation, we'll get the elevation that we want. So if we want the elevation of 0 plus 50, we've got to find how far we are from the starting point. 0 plus 50 is 42 feet from the starting point of 8, okay, because we're starting at 0 plus 08. If we take that away from the station where we're at now, which is 50, we'll get 42 feet. If we multiply that by the grade, we'll get the change in elevation. Okay, so we're going uphill 0.19 feet. Our starting elevation here is the elevation at 0 plus 08, the starting point of our pipeline. So if we add that starting elevation, the 221.04, plus the change in elevation, the 0.19, we get the elevation at 0 plus 50, 221.23. All right, we can do that for the other two stations. So the procedure is the exact same thing as we did before. with the one exception that we have a different distance. So if we want to find the elevation at 1 plus 0, 0, we find the horizontal distance between 1 plus 0, 0 and our starting station of 0.08, or excuse me, of 8, 0 plus 0.08, 8 feet. So 100 minus 8 is 92 feet. So we're going 92 feet down the line to get to this station 100. So we're starting there and we're just heading down here now. So that's 92 feet at a grade of 0.0045. Multiply 0.0045 times 92, you get 0.41. Okay, you add that to your original elevation where you started, which is 221.04, and you get 221.45. So that's the elevation at station 1 plus 0, 0. We can do the same thing for 1 plus 50. We just take 150 minus 8 and get 142 feet. Multiply that by the grade, the 0.0045 there, and we get 0.64. Add that to the original elevation of 221.04, we get 221.68. So what we now have are the elevations of all of the points where the hubs were set. So 0 plus 08, 0 plus 50, 1 plus 00, 1 plus 50, and 2 plus 00. All right, now what we want to do is use the level, and we want to find the elevation of the hub. Okay, now if you remember what we did, we set up the level. We took a back sight on the benchmark. Okay, so we had the benchmark there, and we had the rod. We took a back sight on that. So there's the benchmark. And then what we did was we moved the rod from hub to hub, and we took a foresight on the rod that was sitting on the hub there, okay? So that's a back sight on the benchmark, and we took one back sight to get our HI established. Now a back sight is also called a plus sight because you add a back sight to an elevation to get the height of the instrument right there. So we're going to take 228.16 plus 681 and get 234.97. Now what we do is we then take a foresight on the rod. Now foresights are called minus sights because you subtract a foresight from the HI to get the elevation of the point you're shooting there. We're shooting hubs that are pounded in the ground. Now if you remember from our lab, we didn't move the instrument. The instrument just stayed in one location and we moved the rod from hub to hub. What that means is we take 234.97 minus 6.61. Then we use the same HI and subtract off 6.56. Then we use that same HI of 234.97 and subtract off 6.52. 234.97 minus 6.49. 234.97 minus 6.44. So we just keep the instrument in one location and we move the rod. So we just subtract these numbers every time from 234.97. And if we do that, we'll get those elevations. So 234.97 minus 6.61 is 228.36. 234.97 minus 6.56 is 228.41. 234.97 minus 6.52 is 228.45. 234.97 minus 6.49 is 228.48. And 234.97 minus 6.44 is 228.53. So that gets us the elevations on the hubs. Now we've got the elevations of the pipe, those invert elevations, we calculated those. So now what we want to be able to do is to tell the contractor how far down to go from the hub to get to the invert elevation. That way the contractor can use the hub as a reference mark and figure out where to set their pipe. Now you've got the invert elevation of the pipe and you've got the elevation of the hub. So if you take the difference, if you take the invert elevation minus the hub elevation, you'll get how far down to go. Okay, these are always going to be negative numbers for pipes that are buried because they're below the ground. And the negative on that number means cut. So what I do, I take invert elevation minus hub elevation, and I'll get how to get from the hub to the pipe. They're always negative numbers here every time, which means they're all cuts. And they're all cuts because the hub is on the ground, the pipe is below the ground. So the pipe invert elevation is always below the hub. So just by taking that difference, invert elevation minus hub elevation, I get the cuts. All right, the last thing that I could do here would be to write up a lath. You would put a lath, which is a tall, thin piece of wood, next to the hub. The lath has the information written on it that tells the contractor how to get from the hub to the invert elevation. So what we're telling the contractor here is go over 10 feet, cut 732, so go down 7.32 feet to the invert elevation, i.e. invert elevation of station 0 plus 08. And that's how we'd write up the lath. So that's how to complete a set of grade state calculations.